Welcome to my presentation about determining perceived text complexity, where we evaluated German sentences through student assessments. Our aim and research questions were to improve existing text complexity models by incorporating person-related features. Most text complexity models in NLP research just focus on linguistic components, but we wanted to enhance them by the reader's background. So our research questions are if machine learning models are able to predict a sentence's complexity as it is perceived by teenagers of different backgrounds. The next question is if complexity predictions become more accurate when person-related features are considered. And to do that, we trained multiple machine learning models and evaluated them. And in the last step, we also evaluated how the different features like age, gender, or school grades affected the perceived text complexity. Yeah, therefore, we collected our own data set, which we have collected at different German schools, where the students had to rate the sentences by their complexity, but also were asked some questions about their personal background, like I've stated, age, gender, school grades, the language they speak at home, for example. And we used this data to train multiple models. So in the first step, we train a model that does not look at the features, which is just a fine-tuned BERT model that does some average predictions for the text complexity values. And in the second step, we combined the average predictions with person-related features. So we've noticed that the models that use person-related features tend to perform better in the individual predictions. And also that the KNN and XGB ensemble model was the best model here. In total. But if you look at the single models, the KNN also performed really well. This leads to the conclusion that including person-related features into text complexity models might be beneficial. In the next step, we did a Shapley additive explanations analysis for the feature interpretation. This basically means we have retrained the model on different subsets of the features to isolate the features and see how different feature values, like low or high feature values, impact the predictions up or downwards. And we noticed that the highest impact of the personal features was caused by the maths grade, the German grade, and the language spoken at home. This can be seen in the following diagram, where we have an x-axis showing how the predictions got shifted up or downwards. A negative value means that the prediction got shifted towards the easier side of the complexity, and a higher value meant that the text complexity got rated as higher. And on the left-hand side of the diagram, you can see the different feature names that we have collected in our data set. And each dot in this diagram basically represents a sentence that has been predicted by the text complexity in our model. And each dot has a feature value point that has a color gradient reaching from low to high, where low is the blue color and high is the red color. And this can be used to see how a low or high feature value impacted the predictions. And the TCDE predictions, for example, they come from a BERT model that predicts average text complexity values, and we can see that there's a mostly linear relationship. So if we have blue-colored points, the SHAP value gets lower. If we have red-colored points, the text complexity gets higher, which is really to expect in this context. But you can also see the person-related features. It gets really interesting. Like the language at home, for example, was a categorical variable where the students could state if they speak German at home or not. And you can see that students who spoke German at home have a low feature value in this case. So the low feature value is on the left-hand side, and also shows that this shows us that the text complexity model chose to shift the prediction downwards if a student was speaking German at home, and shifting the text complexity values upwards if the student did not speak any German at home. And this can be done for each of the features on the left-hand side, and it's really interesting to see. Thank you for listening.